Hello there guys, welcome back to another video. Now make sure that you're fully awake for this and you have your verb band ready for full verb band, full explanation for working out. We want to know if we get something wrong, what can we do in the future to fix this up. Now let's get started. The first question about EM wave. Okay, so we got EM wave there, so EM wave. Now we have radio wave, so this is long wavelength, and then the wavelength start getting shorter and shorter and shorter, shorter and shorter, 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 shorter. Then we have X-rays, shorter, 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 shorter. And then we have gamma ray, which is even shorter wavelength. Now, this is where we go. We have two parts that are missing. The first part is A. Okay. Now we've got radio wave, microwave. So what is next to microwave? So this is going to be infrared. And then we've got visible light, and then we have blank, we have X-ray. So what's next to X-ray? So this is going to be ultraviolet. Okay. Now, give a use of microwave. Now, microwave, what do we use microwave for? We think of the basic use. So we use microwave to heat food. So heating food. Okay, so this is the basic one. Now, we have another question we've been repeated. Again, so if you got this correct, that could be a bonus mark there for you. Again, so why do we use microwave again? So we could use it again for heating food. Okay. Now, for those of you who've talked about something else, we can also use it for communication. Okay. Now, it's one mark. I will not be specific what kind of communication. I'll just say communication there. Full stop. Now, use of gamma rays. Now, why do you use gamma rays? Now, look at the diagram I've drawn. Gamma rays, they're very small. The wavelength is very, very short. Extremely short. So, therefore, there are few uses. Now, we use it to sterilize. So, we're sterilizing equipment. So, medical equipment. We can also use it to sterilize food as well. So, that's one. Now, I'll give you a few more, so this way you can have it. So we use it to treat cancer. Treating cancer. Not to cure cancer, but to treat it. Okay, to treat cancer. And then we can also use it for medical imaging. Okay, so later on when we do radioactivity, you're going to see this one. But the main use would be these two, if you know. Again, so it's one mark, you need to pick any of these ones, any one of these. Okay, now let's move to the next one. Now this is Hooke's law. Okay, now Hooke's law, this is Hooke's law. Now you have a few options. Now Hooke's law, what does Hooke's law say? So we want to sketch a graph that obeys Hooke's law. So this tells us that what? It tells us that force is directly proportional to the extension as long as it is within the limit of elasticity or proportionality. Elasticity. Okay, so therefore, what we're going to have now on the x-axis and y-axis is going to be fine. So we can have extension here. This would be in meters. We can have force here. This would be in Newton. So therefore, we need to draw a straight line graph that obeys Hooke's law. Therefore, a straight line graph. Here we go. A straight line graph. And that's it. Now you get the mark for labeling. So label. You get a mark if it passed through the origin in a straight line graph as it obeys Hooke's law. Again, so if you're not sure, that's what it means. Okay. Now, if for those of you who gone beyond, and do this, for example, okay. Now what we need to do here is we need to put the points. So this point here, at this point here. Let me just change the color. At this point. So at this point, the red point, this is where it stopped obeying Hooke's law. So therefore, what we need to say, this is the limit of proportionality. Okay, so this is the limit. Now, what happened is the force has increased so much that it just extend forever. The force has increased so much, so therefore if you apply a small force, so look from here to here, so this is a small force, so from here to here is a small force, so look how long it has extended by. So this is beyond the limit. Now the question tell us we want to stay within the limit, so this is what we need to do. We need to only the straight line, so therefore I can get rid of this. Okay, so only the straight line graph we need, because it obeys the Hooke's law. Okay, right, let's go to the next one. Okay, now we need to work out the resultant force. The resultant force would be 3 take away 2, 1.2, and it's going to go upwards. Therefore, this will be 1.2 up. Okay. Now work out the acceleration. So this will be Newton's second law. So Newton's second law, F is equal to ma. Now we know the resultant force already. So I'm going to rearrange this first. So A is equal to F over m. Resultant force we know. So here we go. So 1.2 divided by mass, which is 0.2. This will give me 6. Therefore, the answer is 6. Okay, nice one. Now explain how the magnitude of the acceleration changes. So how the magnitude of the acceleration changes from the instant the object is released until the first time the object returned to its original resting point in terms of forces. So we need to talk about forces. Now let's take what we got in the diagram. Okay, so here's the object. Now the object's pulled down and then released. Okay, so what we've done, let's take a look. So the object's pulled down. So as the object is pulled down, we got this one. We have this force. Now when it's released, the instant released, there's a resultant force pointing upward. So this is the resultant force. Now we've calculated the acceleration, which is 6. So therefore the acceleration by which it goes up is going to be 6 meters per second squared. Okay. Now the question says, what's going to happen to this as it returns to rest? Okay. So what happens to this as it returns to rest? Now, let's think of this. So we've put it down. So this means that the extension has gotten longer. And then we release it, it accelerates forward. Okay, so accelerate forward. Now what's going to happen? So what's going to happen is this extension is going to go down. Like this. Go down. And then, now we know it's going to, so it's going to go up. And then it's going to come down a little bit. And then this is going to get smaller. Okay. Until it eventually stops. So what does this tell us? This tells us that acceleration, okay, is going down until it reaches 0. Okay, because you pull it, you let it go, it goes up, and then starts swinging a little bit, less swing, less swing, less swing, until it goes to 0. So the first thing we can say about acceleration, okay, so we can say, all right, so from release till rest, the acceleration decreases to 0. Okay, because at the start, once you release it, it is 6. We calculated it, and then it's gonna swing slow, 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 and then goes to 0. That's what it means. So it decreases to 0. That's the first point. Okay. Now the second point is what we know is we know that the extension, okay, also decreases. Because if you use logic, that's what's happening. Because look, it was extended, you release it, the extension gets shorter, shorter until it goes back to its original place. Okay. All right. Now, if the acceleration is decreasing, what can we say? We can say that the resultant force on the object, because we know the resultant force on the object was 1.2, and what happened is acceleration goes down to 0, so therefore the resultant force is equal to decreases to 0. Okay, decreases to 0. Now, one thing I want to keep in mind is the weight of the object. The weight of the object is the same. Look, we are not changing the object, so therefore the mass of the object stays the same, so therefore the weight of the object stays the same. Okay, so this is 3 marks there. Okay, so let's take a look at this one. So look at this. So nothing happened to the bottle, so nothing. So therefore, we got the bottle. So therefore, we got the bottle there. Okay, so nothing happened. So therefore, the pressure outside and the pressure inside, they are equal. Okay, so the pressure outside and inside are equal. So if the pressure outside is 80, it means the pressure inside needs to be 80 as well. So this would be 80 kilopascal. Okay. Now here we go. The airplane descends, the air pressure changes, the plane lands, and notice this happened. Now for this, why did this happen? So why is it like this? So this means that the pressure outside. Now look at this. So before it's sealed up. Okay. So the pressure inside was 80k because we know this. How do we know this? Because of this question there. Now, for the bottle to shrink, this means that the pressure outside, this pressure here, must have been greater than 80. So therefore, there's a resultant pressure that press on the surface of the bottle, so therefore shrinking it. That's 2 marks. What can we say for 2 marks? Okay, so we can say, so where is it? Yeah, so we can say, so the pressure in the aeroplane increases. Okay, so increases. Alright. Therefore, there's a resultant force acting inwards on the bottle. So therefore what we can say is we can say that the pressure of the pressure in the aeroplane, the pressure in aeroplane is greater than pressure inside bottle. Okay, so this is what we can say. So the pressure, there's a greater pressure, there's a pressure difference. The difference is the pressure outside is much bigger than the pressure inside, so therefore there's a resultant force that presses on the bottle shrinks down. Now this one is a straightforward question, we've done this one plenty of time. Okay, so let's get started. What happened? So we got the particles, so the air particles, so air particles, what do? They collide. Okay, they collide with what? With the wall of the bottle slash surface. Okay, what happens? This exerts a force on that surface, and then we have pressure is equal to force over area. Now collide with the wall or the bottle, the surface of the ball, so this is linked together, and then every time they collide they exert a force on that surface. So this will be 1, this will be 2, and this will be 3 marks. Okay, now this is a good question there. Now first of all, we want to identify where is 22nd. 22nd is here, so at this dot. Let me zoom in so this way you can actually see. Okay, now so this is something that you've done in maths, so we need to draw a tangent. It tells you here draw a tangent. Now tangent is going to be a straight line. Now let me just pause and come back to this straight line there. Let me just pause and come back and draw the straight line. Alright, so what I've done is I've drawn a tangent. Now look at this tangent. The tangent is passing through this point here. It's passing through this point. So therefore what we need to do is we need to work out the gradient. Now, the acceleration is the gradient. Now, how do you work out the gradient? Oops, okay, no worries. Looks like my tangent is moving with me. Okay, let me go back. Let me just fix this again. Okay, no worries. I'll come back to this. So the gradient, the tangent is going to be the change in the y over change in x. Okay, now let's fix the tangent again. Let me just get rid of this and come back. Okay, now change y over change x. So we need to see this. Now, where's my change of y? My change of y is going to be here. So this here is my change of y. And then my change of x would be from here. So this here would be my change of x. Okay. So therefore my change of y is going to be 60. Take away, so 60 is here. Take away 20. Divided by 40. Take away, this would be somewhere there. It's counted as this point here. Let me just pause and count the square. Okay, so therefore this is going to be 4. Now therefore my gradient is going to be 1.11 meter per second squared, and this is the thing. Okay, now the math scheme need to see whether you've drawn your tangent properly. So the tangent, look at the tangent, is all the way. You see where I started here? All the way through. And you can see my triangle. Now the gradient is, we need to see, the math scheme also tells us that we need to see that you're attempting to work out the gradient. Okay, so this is the gradient that gives us the acceleration. And then, now the math scheme allows a range. So for example, if your answer is between 1 and 1.2, this will be 3 marks, only 3 marks. Okay, now if your answer is between 1.05 to 1.15, this will be full mark, 4 marks. Now you can see that my answer is between, yes, it is between so the range of my answer is shorter. So my answer falls in this shorter range here. Okay, so this range is very, very short. So therefore my answer is within the shorter range. Therefore I'll be awarded full marks in this case. Okay, so you can see that. Now, why was I able to get the answer precisely? Well, the answer within this short range is I was able, because I drew my tangent, and once I've drawn my tangent, I worked out the triangle, which is the change y, change in x, and I've used most of the triangle. You can see most of the tangent here. You can see how large this change of y is and change of x is. Okay, so for us to get the mark, we need to be able to do this here. Alright, now let's go backwards. Let's go down now. Okay, I'm gonna get rid of this tangent. If you're not sure, again, so this is the tangent there. So the line in blue, here we go. This is the tangent. Let me just trace over it. So here we go. So this way, if I removed it, it should still be there. It's not perfect, but it needs to be straight. So again, you need to use a ruler there. So you guys use a ruler, because on the computer does not allow me to use a ruler. Therefore, the answer is going to be here. Okay, now this question in particular is looking for the method. You need to be careful there. Now, how can you work out the distance? Now, the distance is the area under the graph. Okay, so this is something from there. Now, in the first 80 seconds, let's go back to the diagram and let's identify the first 80 seconds. The first 80 seconds is here. So therefore, we need to work out the area of the whole thing. So what I'll do now is I'll get rid of this diagram, just pause and come back. So we need to work out the area of this whole shape here. Okay. Now, this is not a circle. Okay, so look at that. Look at this here. So this looks like here, here, here. It looks something like this, yeah? It's not a circle. This is not a circle. Okay, doesn't matter how much you force it, this is not a circle. So we need to use some brain power there. How can we do this? Now, there are two methods. The first method is you can work out you can count the square. Okay, you can count the square. to work this out. You can count the square there, how many squares we have, blah 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 blah. It will take you a long time to do this, but it's going to be precise. Okay. Well, the second method is just turn them into triangles and so on. Okay, turn them into triangles and so on and so forth. See what can you do. Okay, see what can you do. Okay, now, so for instance, we can see, what can we see? We can see that we got this there. We can do something like this if you want. You can do something like this if you want. Like this if you want. There's so many stuff that can be done. Okay, now let's zoom in and see what can we do. Okay, let me just pause this. Alright, so what I've done is I paused the video and then I've dissected my diagrams into these kind of diagrams. So what I've done is we're going to end up with some trapezium. So we've got trapezium here, we've got a triangle, we've got the rectangle, we've got a rectangle, we've got trapezium, and then we end up with a trapezium. So let's work out the area of these shapes there. Okay, so therefore I'm going to do it here so this way you can actually see. Alright, so number one, the area, number one area. Now area number one is going to be half time base time height. So half. Okay, you know what? Let me just pause the video and then put the numbers there. Put the numbers on the diagram so this way you can see much better. Okay, so what I've done is I've looked at the squares and come back. So therefore, number one is going to be half times the base. So that is from 20. So that's from 20. So the base is going from 20 to 18. So I'll just put there 20 take away 8 times the height. Now the height is from 20 to 30. So I'll just put it there. So 38 take away 20. So this way you can actually see what numbers I'm using for the base and for the height. And number two, what's number two? Number two would be a trapezium. Now trapezium, you guys know, be half time based. Wait, the parallelograms is going to be base, so it'll be 20 plus 12. So we're going to be here 12 times the height, which is 20. Okay. So number three, where's number three? Number three, just a rectangle, big rectangle there. So you get from 20 all the way to 80. So that's 60 times the height is 20. So number four is the same thing. So we've got the same thing, 60 times. So from 38, so from 20 to 38. So that is 18. And number five, we've got a trapezium there again, so it'll be half times the parallelogram. The parallel lines would be, so from 20 all the way to here, it'll be 60 plus, oh, I forgot, so 20, so this is 36. So from here all the way down to 80, so this would be 44 times the height. So this is the height, so this is the height there. So the height would be from 50 to 38. So that will be 12. Again, you can actually see, I'll put all the numbers there. So this here. Okay, 6. Almost there. 6 again, trapezium. So half times the parallelogram. So this will be, okay, this would be from here, from 36 to 80. That will be 44. Plus the other side is going to be from 56 to 80. So here, so this one here is roughly 56 all the way to 80 there. So this will be 24 times the height, which is a very small height. Oh, wait a minute. Okay, so 40. Oh, I need to be careful here. So 44, 20. Yeah, so this is the height. So the height is going to be from 60 to 50. So this is going to be 10. And the last one, 70, going to be half again times. So this will be 24. Plus 72 to 80, this is 8 times the height, which is going to be 60 to therefore. Okay, now let me just plug this on calculator and come back to you guys. Let me just pause this. Alright, so I've added all the numbers here on the calculator, you can see. So therefore the total distance would be 3736. So therefore this is the answer. So therefore I'll translate the answer there. Let's go down. Let's go down. Here we go. Therefore, it would be the area of 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7, and this gives me 3 3773 meters. So therefore, this is the answer: 3736 meters. Okay, so this is the answer. All right. Now, the range. Again, so depending on what kind of answer you've done. Now, the range, if you got a bigger range, so if you've got the range from 3200 to 4200, so this will be 3 marks. Given that you've done some good working out there. Now, if you got 3500 to 4000, this will be 4 marks. Okay. Again, depending on your working out, you've done some good stuff. And then the full mark you get if you got between 3700 to 3800. So this will be 5 marks. You can actually see that my answer is within this range. Okay. So therefore, how am I able to get the answer within the smallest range? Is because of the shape. Okay, there's nothing complicated there. What I've done is I split it into triangles. So there's one triangle which I can see. Now, if you want to split them into more triangles, it's up to you. So number 1, you can see number 1 is triangles, how based on height. Number 2 is trapezium. Number 3, 4 is a rectangle, and everything else I just left it in trapezium in this case. Okay, if you want to do in triangles and square and rectangle, it's up to you, as long as it works. So therefore, this is my answer in this particular case. Okay. I'll delete this one because we are here to know why is the answer this way and how to get the answer correct next time if we happen to get a question like this in the future. Okay. Now, after 80 seconds, what happens? So let's take a look after 80 seconds. After 80 seconds, the line is flat. The line is flat. What does it tell us if the line is flat? Okay. Now, first thing, if the line is flat, it tells us the speed equal to constant. So it is going at constant speed. Right. Now, why is it going at constant speed? This tells us that the forces are balanced. Okay, so the forces on the vehicle, on the car, are balanced. Okay, let's take it here. So this means the force. So this means that the driving force. Where is it? So this means that the driving force equal to the air resistance. Okay. Now it is 3 marks. What else we need to say? Okay. So if the force is balanced, this means that there's no resultant force. Therefore, no acceleration. There we go. 3 marks. Now this one is nice, straightforward. Okay, so describing a method for a student to use accurately to determine the mass and the volume of each rock. So, okay, so here we go. Now this is what can we do? Right. So first of all, mass. So use a balance to measure mass. Here we go. Right, now remember, mass is not weight. Okay. Now use a balance to measure mass of each rock. Okay, down. Now next one, what we're going to say. Right. Okay, so we're going to use a measuring cylinder. Use measuring cylinder and fill with certain amount of water. Then record the volume. Okay. Next one, we're going to do what? We're going to gently lower a rock into the cylinder. Okay. So the water level rises up. Okay, so we're going to record the new volume. Okay, so new volume. Alright, so the difference in volume, so means the new volume take away the original volume gives us the volume of the rock. Okay, now we're going to make sure we're going to lower the rock into the cylinder. Okay, we want to make sure that it is fully submerged. Okay, fully submerged. All right, we gently lower it because we don't want any water to be spilled up. Okay, now, so what we want to do, what does it say? Accurately. Okay, accurately. So accurate. Okay, so what we're going to do, we're going to, okay, so make sure to read the measuring cylinder at eye level. Okay, eye level. What? Eye level. Then wants to repeat all the above with different rocks. Okay, so here we go. That's 5 marks. Got 1, 2, 3, 4, 5, 6, 7. Got 7 marks there. Want to be careful because we're also looking for accuracy in this case. Okay, so we use a balance. So we use a balance, yeah, to measure mass of each rocks. Use a measuring cylinder. Okay, and so on and so forth. Check again. Make sure you do understand what's going on. Anything else, let me know. Okay. Now, what's the equation? Density is rho is equal to mass divided by volume. This is easy, yeah. Now look at the results, bro. Which one's different? So what we're going to do here is a different material is equal to different densities. Okay, because so far we've been calculating densities, so this means that different material will have different densities. So what we need to do is we need to work out the density for A, B, and C. So therefore A, we need to work out density. B, we need to work out density. C, we need to work out density. Okay, so let me just zoom out very quickly. So the mass, now I will leave it as it is in terms of gram per centimeter cube. I will not do anything crazy. So mass 15 divided by 6, so this will give me gram meter cube. This will give me 13 over 6.1. This will give me something about cube. This will give me okay. So we've calculated the different densities. There we go. All right. Okay. So rock A has a different density compared to rock B and C. Therefore rock A is made up from different materials. Okay, so therefore the student is correct. Okay, now this is how many marks is this? 4 marks. So we need to look at the diagram, look at the data, use the data. We've used the data. You can see we use the data here, and then from the data we've justified the conclusion, which we did justify here. Here we go. Nice and easy marks. Nearly there, only done. Now we need to calculate the speed. Now speed is, oh, we know the speed already, so we don't need to do anything. So speed is this much, and we need to convert. All right, so speed is equal to miles per hour. Okay, 1 mile is equal to this one. So therefore, what we're going to do first, we're going to do the miles part. So this is 4 miles per hour. Now watch this. Let me see whether I can do this. 2 marks here, guys. Easy 2 marks, yeah? Easy 2 marks. Look at that. Easy 2 marks. They're giving you for free. Everything is there. So let's watch this out. Times. We know that 1 miles. Oops, let me use a red pen. 1 mile is this much. So therefore, this many miles times this. Done. Divided by hour. Now, how can we turn hour into second? So 1 hour into seconds, what do you do? 60 times 60. Done. Okay, so 60 times 60 done. Look at that. Look at how easy it is. Look how easy it is. Now you guys know this from like, you know this from like I think you did this in like what? Year 5 conversions or something like that. You done this in year 5. Look at that. Look at that. So from miles to meters is given to you. You multiply from 1 hour to seconds. Look, 60 and 60 done. So therefore, the answer is going to be 179. 179. Look how easy it is to get 2 marks. Yeah, you don't need to overthink too much. Yeah, so this is like your 5 stuff, conversions. Now during the test, blah blah blah, 2 marks. Okay, we've got 2 marks. We've got mark. Okay, call it mark M1. So mark 1 and 2 mark 2. Okay, so what do we need to do there? Okay, so determine the speed where it goes from here to here. Okay. Okay, so here we go. So the distance we know is known. Distance known. Now we need to find a way to work out the speed. Alright? We need to work out the way to work out the speed. So we need distance, we need time. Okay, we need time. Alright. So we're going to measure time taken from first marker to second marker. Okay, so how am I going to do this? Using a stopwatch. Okay, so what's going to happen is when the vehicle pass the first marker, you start the timer, and then you start the stopwatch, and then when it reaches the second marker, you stopped it. Okay, so I'll say start when passing first marker, and when passing second marker. Okay, and then so using speed equal to distance over time. Okay, so here we go. So these 3 marks. Here you go. 1 mark for saying what to measure and what to use to measure it, and this one because the distance is known. Yeah, the distance. The question tells the distance is known. Okay, next one. Oh, that's the last one. Now, constant speed. What does this tell? Now, this constant speed, it means that there's no acceleration. If there's no acceleration, this tells us that there's no resultant force. If there's no resultant force, this tells us that the forces equal to balance. Okay, now the arrow should be started from the center, but unfortunately it does not. So what we need to do is we need to look at this length. So therefore, we need to look at this length here. So this length, and then we need to, because remember the four cylinders need to be equal. So therefore, how can we do this? Okay, so therefore it's going to be something like this. Okay, so this will be, so it has to be balanced. It needs to be opposite. It needs to be opposite. It needs to be facing to the left, and then this will be air resistance. To the left, equal. So here we go. So equal, opposite. Okay, and going to yeah. And this is air resistance. So this is the last question. Nice and easy mark. 3 marks you're getting for that. Yeah. How generous are they? So end of the question. Again, so make sure that everything is fully ball bent. So hopefully things that you didn't know now you know, and you can be awake for the future.